So I'm Mikhail Lukin, and I'm a chief scientist here at QuEra. So I should say that maybe there has been several inflection points along the way, and it goes back to like 20 years ago when we first started, actually 25 years ago when we first started thinking about these ideas. And at the time, it was very clear that it's an exciting direction which will emerge sooner or later as one of the leading, is not the leading approach to building quantum computers. So the second moment came maybe about 10 years ago when by then many groups have been working on this platform with various degree of success, and it became very clear for us that there is really nothing which stands between what we really literally knew what to do at the time, 2016, 2017, and really advancing it to the point where we can actually start thinking about this, large-scale, slow error rate regime. So then there was yet another moment which happened about 2 years ago, where for the first time we actually started implementing complex algorithms with this protected logical qubits. By then that was definitely the first time, anyone has ever been doing that. And it brings us to the moment today where we actually, again, for the first time, implemented and combined together all elements which require one to operate this kind of large utility scale, machine. And I would say with that, we really establish very solid scientific foundation for the first time in history. And I should say that at this point, these kind of dreams and ideas, that many of us had for 30 years, for the first time, they're really in direct sight. Right? And this, I would say, moreover, I think this is a very special time in the history of quantum physics, quantum technology, and maybe technology more broadly. And we are here at a very special place where we are in a position to really, realize these ideas and dreams. The fault-tolerant, large-scale, utility-scale quantum computers are quite complex objects which require many elements, working together. And one of these elements are low physical error rates, and basically operating what's called, threshold, error correction threshold. But it's only one element. In addition to that, you have to not just protect the qubits during their memory, which is probably the easiest and maybe even the least relevant task. So what you need to do, you need to actually build logical circuits from these encoded qubits. Moreover, you need to learn how to do universal operation. And that means really building an arbitrary, essentially analog, evolution with digital precision. It also means that you have to basically realize systems which will allow you to essentially extract entropy as you do kind of circuit multi-step, days and weeks long calculations, and all of these things are both, huge challenges, but they're also huge opportunities. So what it really means is that you really have to kind of push along all of these directions, and then combine them, in a creative way. And that's the value of co-design. That's why we're entering now the special time in the history of the subject. So what's unique about quantum computing and quantum information is that this is a subject which really spans a lot of different disciplines of, physics, computer science, engineering, chemistry, and it also transcends the boundary between basic science, engineering, and application development. So what we are trying to do, it's kind of unprecedented in history. We are trying to now engineer systems, while at the same time still, pushing the frontier of basic science. And this actually is very challenging. Some people think it's crazy, but this is what really is needed for this field to succeed. And in fact, this approach, this integrated approach, is what really allows us to basically change the slope of the development, to accelerate the progress, in some cases by years, maybe even by decades, And that's what is our secret sauce. What we are trying to do is very challenging, and it's still, there's a lot of kind of innovation and discovery involved, but at the same time, we know enough already now to start building systems, to start addressing applications, and that's why this is a very special place. Yes, I will just repeat that, it is a very special time in the history of, quantum science and technology. And, we are at a very frontier, if you're really kind of pushing it, realizing this quantum value at scale, something that people dreamed about for nearly 40 years by now. And this community here, it's a very special place.